Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. Just 1 minute, let me check. Yes. All right. So here is my profile. I am Jeetendra Dixit. I did my BTech from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for last 11 years. Right. So I teach mathematics, and today I'll discuss transformation of graphs. Okay, so we'll start transformation of graphs, and we'll continue in other sessions also. And in transformation of graphs, I'll cover all types of transformations, whether it's shifting along x-axis or along y-axis, or putting mod on x, y, fx. Similarly, putting any other function like signum function, fractional part, and greatest linear function. All right, so all types of transformation will cover in this, and after that we'll learn curve sketching using calculus also. Okay, so in this series I'm going to cover all types of curve sketching. So I hope it is clear. Now let me tell you about the Unacademy subscription before we begin. So as you know, Unacademy is India's largest online learning platform, and if you want to get a subscription on an academy, then there are two types of subscriptions you can take. One is plus subscription. All right, plus subscription, and second is iconic subscription. So when you take plus subscription, you get access to daily live classes of all the educators, unlimited access. All right, so all the India's top educators are teaching on the platform, and you will get the access to their courses. You can follow any educator of your choice, so there's no restriction. That is up to you. And you can watch their live session as well as recorded sessions also. If you miss something, you can watch their recorded sessions. You can download the recorded sessions and watch them offline also. All right, then you can ask your doubts also during the live classes. Other than dedicated doubt sessions, there will be dedicated doubt sessions also. Live tests and quizzes will also be accessible to you, and all these courses are structured as I told you, that everything is pre-planned, so you can see the schedule of all the upcoming lectures in well advance. These are the subscription charges. 1 year subscription charges 38,500, and 2 years is 56,000. You can subscribe one, 3 and 6 months also, but these are the best economically. Uh, I mean, compared to any other package, these are the better packages. 12 and 24 months economically, and also it helps if you are preparing for JEE. Then you should continue. You should, if you're following a course, then you should follow it for an year or two. All right, and these will be the charges after 10% discount. So if you use this code Jeet1, you'll get 10% discount. All right, now let me tell you iconic subscription. So whatever I have told you in plus, you'll get all the benefits of plus subscription in this iconic subscription. And apart from that, you'll get a personal coach, that means an expert who will guide you throughout your preparation for all the top exams like IIT-JEE Advanced, Main, BITS. All right, and your test analysis will be done in a personalized manner. Your personalized feedback will be given to improve your time management and exam approach. All right, and your study planner will also be customized, and bi-weekly reviews will be given to highlight your progress. All right, so this personal attention you're getting in iconic subscription. And these are the charges of iconic subscription: 56,000 for 1 year, and after 10% discount you'll have to pay 50,000. So use this code to get 50%. Similarly, 2 years subscription charges is 86,000. All right, so you'll get 10% discount. Use this code JEET1 to get this discount, and it is 77,400. All right, you can download this Unacademy's learning app from Play Store. Okay, now let's begin the topic, transformations. So let's start from a very basic transformation today. Now suppose you have so let graph of y is equal to fx be. So I'm taking a graph y is equal to fx, a random graph, to plot x and y axis. Okay, so these are the axes. Now let's take this as the graph. Say graph is like this. So this is a good graph. Y is equal to fx. It lies between, say, this point. No need to take it here, but let me write it. This is x1 and this is x2. All right. Or let's write it minus x1. Okay. So now it will represent that it's a negative number. So I'm putting minus sign to show you the difference after transformation. X1 is positive, minus x1 is negative. So minus x1, and this end point is, this is x2. Or let's take this point. Let's take this point as x2, minus x2, and this will be x3. Okay, now it's fine. Now first transformation is, we need to plot the graph of y is equal to, we need to replace y by minus y. Okay, this y by minus y. That means you need to plot the graph of, see, if you put y is equal to minus y in this, it will be minus y is equal to fx. That means y is equal to minus fx. All right. So that means we are going to plot the graph of y is equal to minus fx. And how would you get y is equal to minus fx? By replacing y by minus y. All right. So see what happens. If you replace y by minus y, then what happens? Okay. So it's very simple. I think you can figure it out, right? So transformed graph I'll draw with yellow line, all right? So this graph is going to be transformed, all right? When you replace y by minus y, then whole graph flips around x-axis. That means the graph which lies below x-axis, that will come up, and the graph which is above x-axis will come down, all right? So this graph will look like this. All right, so it will be like this. This is pretty straight, smooth. So this point will remain same, x3. This point is minus x2 as it is. This point is minus x1. Okay. So this is the graph of y is equal to minus fx. I hope you understood. So that means you need to take the reflection of the graph of y is equal to fx about which axis? About x-axis. Okay. So this is the transformation. That means you need to take the reflection of complete graph of y is equal to fx about x-axis. Then you'll get the graph of y is equal to minus fx. For example, say, I'll give you some examples for this. So we are going to take some graphs, standard graphs like x square, ln x, e raised to x, all right, mod of x. So I'm going to use these graphs for examples. Let's discuss these graphs first of all. If you don't know, and these 5 base graphs I'll use again and again. Okay. So graphs which I'm talking about is this. First is y is equal to x square. All right. So you know the graph y is equal to x square. I'll take this as an example for transformation. Y is equal to, second will be y is equal to ln x. So you know the graph of ln x. This will be the graph of ln x. All right. This point is 1, 0. Then I'll take y is equal to x cube, or any odd power you can say. This is y is equal to x cube, third, and e raised to x. y is equal to e raised to x, both, or y is equal to mod of x. Even if you don't want to use, then let's take y is equal to sine x. All right, so this will be sine x, and so on, and this way will continue to minus infinity. Okay, minus infinity to plus infinity. So I hope you have got it. Now let's do the transformation. Okay, so if you do the transformation, then what will be the graph of y is equal to minus of x square? Then just take the reflection of this graph about x-axis. So this will be yellow. Yellow part is the graph of y is equal to minus x square. Got it? Now, how would the reflection look here? If you plot the graph of y is equal to minus ln x, this is going to be the reflection about x-axis again. So this part will come up and this part will go down. This is minus ln x. All right. Similarly, minus x cube will be like this. This part will come up, reflection, and this part will go down. This is y is equal to minus x cube. Now, y is equal to minus e raised to x. So this is going to be completely negative. All right. So this is y is equal to minus of e raised to x. And similarly, take the reflection of sine x about x-axis. So this will come down and this will come up and the wave will continue. All right. This is, got it? So this is y is equal to minus sine x. So I hope it is clear. It's pretty simple. So when you put minus sign, it graph reflects about x-axis. Okay, take the image of complete graph about x-axis. Now let's discuss second transformation. All right. So second transformation is when you replace x by minus x. So as we have replaced y by minus y, then the original equation was y is equal to fx. Now new equation after this transformation, x is equal to, when you replace x by minus x, the new equation will be y is equal to f of minus x. That means we are going to plot the graph of y is equal to f of minus x. Okay, so see what happens. So this was our graph. This point was x1 minus x1. This point was minus x2, and this end point was x3. All right. Now, if you replace, this is the graph of y is equal to fx. Now you replace x by minus x, then what happens? Then whole graph transforms about y-axis. Okay, that means if you were getting for y is equal to 1, you were getting minus 1. Now for y is equal to minus 1, you'll get y1. So let me tell you, let me draw the transformation first of all. So when you replace x by minus x, the graph will transform about, you need to take the reflection of this graph, reflection of this graph about wait a minute. Let's take this point as x3. All right. So this is the reflection of right side part of fx, which is right side of y-axis, and the reflection which is on. Okay, so now let's write the points. What will be this point? This point will become minus x3. You can see when you put minus x3 in this, it will become f of x3. So you'll get the same value which you are getting here when you put x is equal to x3. Okay, so after all, equation will remain same. All right. So when you replace x by minus x, the values which you are getting for positive x, now those values you will get for negative x. In the values which you are getting, values of y which you are getting for negative x, now those values you will get for positive x. All right, that's why this graph is reflected about x-axis. So this is the graph of y is equal to f of, sorry, reflected about y-axis. Okay, this is the graph. uh, if you see what is this point, this point is plus x1 now, right? So domain of this was x was between minus x1 to x3. You can see this was the domain of this function, right? Here also, to find the domain, new domain of this function, you need to put minus x between minus x1 and x1 x3. Okay, this minus x1 minus x should be between minus x1 to x3. That is the domain of f, right? So if you simplify, you'll get x is less than or equal to x1 and greater than or equal to minus x3. So this is the new domain. You can see, right? Minus x3 to minus x3 to x1. This has become the new domain. So in this way, you can find the new domain of the function. Now let's do the examples based on this. First example, same y is equal to uh, see, if you put minus x in x square, there won't be any change. Okay, so let's leave that graph. I'll take other graphs in this case. Y is equal to minus of ln x. Second, y is equal to e raised to minus x. All right, and one more example. Let me take y is equal to. Do you know the graph of fractional part? So I'll take minus of fractional part of x. All right, like this. And fourth, y is equal to minus of greatest integer of x. All right. Now first plot x and y axis. So we need to plot the base graphs first of all. Base graphs means without minus sign. That means in this case, in third case, we'll plot the graph of y is equal to fractional part of y is equal to fractional part of x, and then we will plot y is equal to fractional part of minus x. So base graph, that means graph of y is equal to e raised to x, y is equal to ln x, y is equal to fractional part of minus x. I will plot with white color. So this is ln x, we have already plotted it. This is ln x. This is ln x. This point is 1, 0. This is e raised to x. This y is equal to e raised to x, all right? This is y is equal to fractional part of x. It's a periodic function, right? That's it. Yeah, that's it. Minus 1, minus 2, 0, 1, 2, and 3, and so on, right? Now this is greatest integer function. Like this. All right. Now let's start. So first we are going to plot this y is equal to ln of minus x. So that means take the reflection of this graph of y is equal to ln x about y-axis. All right, about y-axis. So this is going to be the reflection, complete reflection of graph of y is equal to fx. So because this white graph lies completely right side of y-axis, so this yellow will come, reflection will come completely left side of y-axis. So this is the graph of y is equal to ln of minus x. Okay, and domain is obviously domain of ln of x was 0 to infinity, so domain of ln of minus x will be minus infinity to 0, right? So in that way you can write the domain also, either by the concept of domain or by looking at the graph also. Okay, now this point will become minus 1 comma 0. You can check if you put x is equal to minus 1, this you'll get ln of 1, and ln of 1 is 0, right? So I hope it is clear. Now take the reflection of this graph. This point is 0 comma 1. So if you take the reflection about y-axis, the reflected graph will pass through this point only. Okay, they will meet e raised to x and e raised to minus x, or you can say fx and f of minus x, where they do meet. See this point? This point was where this y's graph of y is equal to fx cuts the y-axis. So at that point, they both will cross each other. All right. So here they will cross each other like that. All right. So graph of fx and f of minus x meet each other when x is equal to 0. All right. Remember that. So this is the graph of y is equal to e raised to minus x. Domain here, graph of domain of e raised to x was all real numbers, so domain of e raised to minus x is also all real numbers. Now let's take the domain of y is equal to, let's plot the graph of y is equal to fractional part of minus x. We have already plotted the graph of y is equal to, this is the graph of y is equal to fractional part of x. Now let's do the transformation. So if you do the transformation, this part will come, if you reflect this part, okay, this will be like this, and this part will remain open, right? Open. So open will coincide with open part, and this will come like this and like this. Okay, so lines will be now like this. I hope you got it right. So this is fractional part of minus x. Now take the reflection of this greatest integer of this is the graph of y is equal to greatest integer of x. Now we need to plot the graph of y is equal to greatest integer of minus x. So first take the reflection of this part. So reflection of this part is, okay, minus 1 to 0. Then this will be minus 2 to minus 1. Then like this, right? And like this, like this. Got it? This is the reflection. So this is the graph of y is equal to greatest integer of minus x. So I hope you have got it. I'll tell you one more example. If you know the graph of y is equal to, say, x square plus x plus 1, and you replace x by minus x, then you'll get this equation y is equal to x square minus x plus 1. Okay, so basically these two equations, you can see these quadratics are very famous quadratics, right? So basically they are reflections, their graphs are reflections of each other about y-axis. Okay, let's plot them. Very interesting. So in any quadratic you can do such thing. Whenever you replace x by minus x, just coefficient of x will become negative. That means ax square plus bx plus c. In this equation, if you do the transformation ax square plus bx plus c, the new equation will become ax square minus bx plus c. All right. So just coefficient of x becomes negative. Okay, so I'm plotting the graph of this. Y is equal to x square plus x, the base graph, then transformed graph. So this graph, its vertex is minus 1 by 2, comma 3 by 4. Okay, this is the vertex, and it's completely above x-axis because discriminant is less than 0. You can check. Graph will be like this. This point is nothing but 0 comma 1. All right. Now let's plot the transformed graph. So that quadratic will be like this. Now what will be the vertex? Using reflection, you can write the vertex, or using the formula, do it anyways. It is going to be, this point is going to be plus 1 by 2, and y coordinate will remain same, 3 by 4. Okay, so x coordinate will become negative. So this is the graph. Got it? So I hope you are done with this reflection. Now let's do shifting. Okay, so what we have done, we have replaced x by minus x, and we have replaced y by minus y. So two transformations are done. Now let's move on to other transformations. All right. The next transformation is when you replace x by x plus a. Okay, a is a positive number. Let's take a positive. So when we need to replace by x minus a, then we'll redo x minus a. All right. So the y is equal to fx. This graph after this transformation, when x is replaced by x plus a, the new equation will become y is equal to f of x plus a. All right. So see what happens. This was our base graph. Y is equal to fx, right? Let me plot the points also. This was minus x1, minus x2 if required. This is minus, this plus x3, all right? So this is our base graph. Now let's plot this. Y is equal to this transformed graph, okay? See, when you replace x by x plus a, what will be the new domain of this? Domain of this is x belonging to minus x1 to x3, right? Now, this x plus a should be between minus x1 to minus plus x3. And then you can see this new domain of this graph will become minus x1 minus a to x3 minus a. That means domain is shifted towards left, all right, by a units. So yes, that is going to happen. This graph will shift by a units, all right, towards left, towards left. So this point is going to be minus x1 minus a, and this point is going to be x3 plus a. So that's what happens when you replace x by x plus a. The whole graph shifts towards left by a units. So see, this is going to happen. What will be this point? This point is going to be minus x2 minus a, all right? And it will be like this, okay? The whole graph will transform like this. Got it? So whole graph is shifted towards left by a unit, okay, along x-axis. Now what will happen if you replace x by minus a, x minus a? So we'll do that here only, x minus a. So if you do that, now what will be the new domain? You can see, then in that case, x minus a should be between minus x1 to x3. And then you can add a, so it is going to be minus x1 plus a to x3 plus a. That means it will be somewhere here. It will start from here, minus x1 plus a to x3 plus a, okay? x3 plus a. So whole graph will shift towards right. So when you replace x by x minus 1, the whole graph of y is going to fx shift towards right by 1 unit, all right? So this is going to be the new graph. Okay, finally you reach to the same height. These 3 points will be at same height, same y coordinate, all right? This is minus x2 plus a. So I hope you have got it. Let me change the color of this third one. Say let's take green color, all right? This is the graph. This is the graph of y is equal to f of x minus a, and this is the graph of y is equal to f of x plus a. Okay, now let me repeat, okay? So when you replace, 1 minute. When you replace x by x minus a, the whole graph shifts by a units towards right, okay, along x-axis. When you replace x by x plus a, the graph of y is equal to fx shifts towards left by a units along x-axis. All right, so that is the transformation. Now let's do it. Now let's practice it. So I'll give you some examples, but before giving you the example, let me draw the coordinate axis. All right, so here y is equal to x square. This is our base graph, and we need to plot y is equal to x minus 1 square, and also second y is equal to x plus 1 square. All right, two transformations. So first let me plot the base graph. This is y is equal to x square, you all know that. Now the second one, let's plot y is equal to x minus 1. So when you do x minus 1, this graph, this yellow, okay, then this graph will shift by 1 unit. Vertex will shift. The point which was touching the x-axis at origin, now it will touch the x-axis at 1, 0. So that point is 1, 0. This graph is graph of y is equal to x minus 1. So you have replaced in this x by x minus 1. Got it? Now let's plot the other one. Now this one. So in this, x is replaced by x plus 1. The whole graph will shift towards left. Okay. So this point is minus 1, 0 by 1 unit. So this graph will look like this. Yeah, it's like this. Okay. So this is the graph of y is equal to x plus 1 the whole square. I hope you have got it. Now let's take second example. So second example is example 2. Y is equal to ln x. All right. This is the example. Now you need to plot first y is equal to y is equal to ln of x plus 1. All right, and y is equal to ln of x minus 1. Okay, this is first and this is second. Let's see what happens. First, let's plot the base graph. This is the base graph. It touches y-axis. All right, it touches y-axis. So this is the base graph. Y is equal to ln x. Now let's plot. I need to plot here two lines. Y is equal to x is equal to minus 1 line. This graph will shift left or right by 1 unit. So you need to plot these two lines, okay? Because graph will always touch a vertical line. This graph of ln x. So it was touching x is equal to 0 line. That is x-axis. Now it is going to touch x is equal to plus 1 or minus 1 after transformation. All right, when you shift it towards left or right. So I'm plotting those two vertical lines first, okay, before plotting the graph of ln x. So always do that. First plot these vertical lines. This line is x is equal to minus 1. This line is x is equal to 1. So I'm plotting this first one, this one. First one is y is equal to x plus 1. When you plot y is equal to x plus 1, this whole graph will shift by 1 unit towards left. Okay, so it will look like this. Like this, right? It will touch x is equal to minus 1 line. It will pass through origin now, because point which was 1, 0 will become 0, 0. Okay, so it will pass through 0, 0. So this is the graph. Now second graph which I'm going to plot is y is equal to ln of x plus x minus 1. Okay, So now this whole graph will shift 1 unit towards right. So it will touch x is equal to 1 line. This is the graph of y is equal to ln of x minus 1. Alright. And now this point will become 2 comma 0. So I hope it is clear. Now let's take another example. So my third example is going to be, which example should I take? Now suppose you have y is equal to ln is down e raised to x is you won't be able to see the difference. So let me plot y is equal to x minus 1 the whole cube. Okay, that's one. And the fourth example, I'll give you y is equal to sine of x minus x plus pi by 4. Okay, so now you guys try this first, then I'll let you know, then I'll plot it. Okay, so you guys first try it. All right, now let's do this. X minus 1 whole cube. So first we'll plot the graph of y is equal to x cube, right? So you know y is equal to x cube is like this. This is y is equal to x cube. Now let's plot the graph of y is equal to this. So you need to replace x by x minus 1. Okay, so if you do that, this new graph, which I'm going to plot with yellow color, will shift towards right by 1 unit. This point is 1 comma 0. This graph will come like this. Okay, so this is the graph. This is y is equal to x minus 1 the whole cube. All right, now let's plot the sine graph of y is equal to sine of x plus pi by 4. So first I'll plot the graph of y is equal to sine x, and you see how would this transformation look like. Plot it. Plot it fast. All right, now let me do it. So if you replace x by x plus pi by 4, all right, in the equation of y is equal to sine x, y is equal to sine x. You're replacing x by x plus pi by 4. So whole graph will shift towards left by pi by 4 unit, all right? So this point is say minus pi by 4 comma 0. The graph will start from here. Not start exactly, but I will shift this point origin, the point which is at origin. I'm just shifting with respect to that point. So like this, all these points will shift. Uh, you need to subtract pi by 4 to all the points which lie on x-axis, all right, to get the new points. So if you want to find this point was pi. Now this point is pi minus pi by 4, okay? This point was 2 pi. Now this point is 2 pi minus pi by 4, got it? This point was 3 pi. Now this point is 3 pi minus pi by 4, got it? This is the graph. In this way, it will shift towards left or right if you replace x by x plus a or x minus a. I hope you have got this point, all right? Now, let's do the fourth transformation in which y is replaced by y plus minus a, okay? So if you replace first, let's do it separately. Y is replaced by y plus a and a is a positive number, okay? That means new equation uh, will become y plus a is equal to fx. The equation y is equal to fx will become y plus a is equal to fx, which can also be written as y is equal to. So there are another way of reading this equation and simple to understand. You can replace y is equal to fx minus a. So that means adding a to y, that means y plus a is writing y plus a is equal to fx is same as writing y is equal to fx minus a. That means adding a to y means subtracting a to fx, all right? Like that means you can subtract that same constant to expression of x. Okay, it will give you the same transformation. You can see these two equations are same. These two equations are identical. Whether you write y plus a is equal to fx or you write fx is equal to y is equal to fx minus a. Now what will happen when you do that? The whole graph will come down. Graph of y is equal to fx will translate along y-axis, okay, and in this case downwards, okay, in this case downwards. And if you replace a y by y minus a, it will be upwards. So it's very simple to understand in this way that when you are doing fx minus a, then all the values will be subtracted by a. So all the values will shift by a unit. I mean, y coordinates will be decreased by a units. And when you do y plus a, if you are doing if you are replacing y by y minus a, okay, then new equation will be y minus a is equal to fx, which easily you can see y is equal to fx plus a, okay? So whole graph will go up. Graph of y is equal to fx will go up by a units. Got it? Now let me show you. Suppose let's take the same example which we are taking. This is the graph of our fx, y is equal to fx. All right. See what happens to this graph when you do y is replaced by y plus a, or you can write fx is equal to fx minus a. Okay. The first one. Let's do with yellow, white color. So the whole graph will come down by a units. A might be an integer number. They both look parallel, right? Yeah, it's like this. So this is the graph of y is equal to fx minus a, fx minus a, which you have got by replacing y is equal to y plus a. Okay, yes. So equation is y is equal to fx minus a. Okay, and second one, let's do it with yellow color. So this will be the graph. It will go up by a unit. All right, like this. Domain will remain same in this case. You can see this whole graph, whether yellow or green or white, all three are lying in the same domain, minus x1 to x3. There's no change in domain. Okay, so this is the graph of y is equal to fx plus a, which you have got by replacing y is equal to y minus a. Okay, I hope it is clear. Now let's do some examples. So I am giving you the examples. You need to plot them. Y is equal to x square plus say 2. Plot it first this, and also plot second I'll give you after this. Example 2, you need to plot y is equal to e raised to x minus 1. Y is equal to fractional part of x plus 2. All right, and the last one. All right, so you need to plot these graphs. In this you need to plot 2. Y is equal to x square minus 2 as well. All right, so you start, I'll draw coordinate axis. You guys start plotting it. I will also give you the base graph, okay, which you need to transform. This is your y is equal to x square, base graph. I'm sorry, this is e raised to x only, the base graph. Next one you need to plot. This is fractional part of x, all right? And the last one. This is sin x. So I have plotted the all 4 base graphs. Now you need to transform them, okay, to get the graph of given equation. All right, so let's plot this yellow part first of all. So when you do x square plus 2, the whole graph will shift up. Okay, that means you're doing y is equal to y is equal to y minus 2. All right, it's the same thing. So you can remember this like you're adding something to fx or subtracting something to fx. So if you're adding something to fx, the whole graph of fx will go up. If you're subtracting something to fx, the whole graph will come down. Okay, as simple as that. Opposite to that, replacing y by my y minus a, or y is equal to y plus a. The whole graph will go up by 2 units. So this is going to be the new graph, and this point is 0 comma 2. All right, so this is y is equal to x square plus 2. You can plot this y is equal to x square minus 2 also. The whole graph will come down by 2 units. Okay, so this point is 0 comma minus 2. I hope you have got it. Now see this one. In this case, the whole graph is going to come down by 1 unit. But see, this graph of e raised to x is touching x-axis, so that means you need to plot this line below x-axis, which is y is equal to minus 1 line. Okay, so now this transformed graph will touch this line. All right, so you need to plot this line first of all. This is called asymptote, and because it was passing through 0 comma 1, now it will pass through 0 comma 0. Okay, you can see like this. So left side you can improve it a little. Yeah, can shift this line slightly up. Wait a minute. Okay, you need to plot this line y is equal to minus 1. Okay, this is the line. It is going to be like this. Got it? So this is the graph of e raised to x minus 1. Now fractional part of x plus 2, the whole graph will shift by 2 units. So this is 0 comma 1. Now this is going to be 0 comma 2. So plot this line. Now this is like your x-axis. The whole graph will go up. So you need whenever you need to take the graph up or down, and it's a graph, so slightly complicated, then plot this line, horizontal line. Okay, and treat this as x-axis. Okay, like it was in the base graph, and just plot the graphs. Okay, copy them. Okay, like this. Got it? What is this line? This line is y is equal to 2 line, and this is the graph of this fractional part of x plus 2. Now in this case, the graph of sin x will go up by 1 unit. So plot this line. What is this line? This is y is equal to 1 line, which will touch this graph of sin x at its peak. Now the sin x will go up. Okay, will come down, will touch x-axis, minus 1 will become 0, then again like this and like this. Okay, so it will be like a parallel graph. Yeah, it is parallel to the original one. Yeah, so this is the graph of y is equal to sin x plus 1. Okay, this line is y is equal to 1 line. Now this peak will become 0 comma 2, and the smallest value will be 0. All right, smallest value of sin x plus 1 is 0. I hope you have got these transformations. All right, replacing x by x plus a or y by y minus a. Okay, so now we have done 4 transformations. Okay, so let's take some example in which we will combine these transformations. Okay, all 4 transformations. Let's see. So I'll give you one example. Now you need to plot this. Okay, this is the first question. Now second one is this. and one more. Okay, let's do these two. Okay, first stepwise we'll go. Sorry, we are doing this example. Yeah. So see how to do it. Okay, let's plot the base graph first. So I'm plotting this y is equal to x square. This is y is equal to x square. Then I'll plot, okay, I'll tell you these steps. First, I'll plot y is equal to x square. Then I'll replace x by x minus a, x minus 1. So I'll get y is equal to x minus 1 the whole square. You could add 4 first, and uh, then second transformation is going to be y is equal to y minus 4. You can interchange these two transformation. This is what I was telling. So y minus 4, so you'll get y minus 4 is equal to x minus 1 the whole square, because adding 4 to fx means subtracting 4 to y. Okay, so you'll get this equation, y is equal to x minus 1 the whole square plus 4. Okay, so first what will happen, because you're replacing x by minus a, so whole graph will shift. This is the second part I'm plotting. The whole graph will shift towards right by 1 unit. All right, so this is 1 comma 0, and this is the graph of y is equal to x minus 1 the whole square. Now when you're replacing y by y minus 4, the whole graph will go up, okay, by 4 unit. So now this vertex, which is 1 comma 0, will go up, and it will be like 1 comma 4 now. Okay, so this is going to be the final graph, right and up. So yeah, here is the graph, final graph. Okay, got it? The yellow graph is the final graph. Y is equal to x minus 1 whole square. So I hope you have got it. Now let me do the second transformation. Okay, so I'm plotting the graph, the base graph, which is graph of ln x. Okay, we'll do the transformations in this graph. And what are the transformations? You need to do two transformations to get the final graph. What are the transformations? I'll write the steps here. So first you need to, uh, okay, I'll write it here. Y is equal to ln x. First, you need to replace y by minus y. Okay, so you'll get this. Y is equal to minus ln x. And then you can do x by x plus 2. So whole graph will shift towards left. So minus of ln of x plus 2 you'll get. Got it? And again, you can interchange these two transformation. First, you can replace x by x plus 2, and then you can do y is equal to minus y. Final output will be same. Okay, even if you interchange these steps. Okay, so first transformation is y is equal to minus y. So what happens when you replace y by minus y? The whole graph, the whole graph, this I'm plotting this, okay, reflects about x-axis. So here's the white graph, white one will represent the first transformation. So here is this is the graph of y is equal to minus ln x. All right. Now you need to replace ln x by x plus 2. So whole graph will shift by 2 units. All right, towards left. So I'm plotting this vertical line because this white graph is touching y-axis. After the transformation, it will touch x is equal to minus 2 line. This is x is equal to 0 line, y-axis. So now it will touch x is equal to minus 2 line. Okay. So graph, yellow graph is the final graph, and it is going to be like this. This point, which was 1 comma 0, this point was 1 comma 0, now will become minus 1 comma 0, and it will go parallel to this, like this. So here is the final graph, ln of this one. I hope you have got it. Okay, so this is the final output. So we have done 4 transformations today, and in next session I'll continue this transformation, in which we'll see the transformation of modulus functions. All right, and when you multiply some constant to x, or when you multiply some constant to multiply or divide some constant to y. Okay, so all these transformations we'll do in our next session. Okay, so I hope you have enjoyed this session. So go and like and subscribe the channel and like my videos. Thank you very much for attending this. All right, bye bye.